Hello everyone, this is Mr. H again and welcome back to my YouTube channel. In this video, I will talk about exponential growth and decay. Please make sure to stay till the end of the video because I will be reviewing some important concepts about exponential growth and decay. Also, I will be solving and explaining some interesting examples. Alright, so let's dive into the important concepts first. Alright, so here's how exponential growth and exponential decay are represented. All right, on the left, so we have y equals a times 1 plus r to the power of t. And for exponential decay, we have y equals a times 1 minus r to the power of t. So y talks about the final amount or the final value. A refers to the initial amount or the initial value. R represents the rate of growth or rate of decay, and T is the time period. All right, let's take a look at example number one. Identify if the given equation represents exponential growth or decay. All right, so for this given set of examples, we need to remember how exponential function is modeled. So we have y equals to a times b to the power of x, right? We need to consider if b is greater than 1, then we're talking about growth. If b is greater than 0 but less than 1, we're looking at exponential decay. All right? So if you're going to take a look at example A, so this 2.7 is A, and this factor right here, 1.17, is considered B. All right. And like what I mentioned earlier, if B is greater than 1, then we're talking about exponential growth. So the answer to example 1A is growth. And for example 1B, you can see here, this is the value of A, and this factor is the B. And since B is less than 1, greater than 0, but less than 1, so therefore that's exponential decay. So remember that this is the growth factor, and this is the decay factor. So let's take a look at example number 2. A radioactive element decays at a rate of 5% yearly. There are 53 grams of the substance present. How much of the substance remains after 25 years? Round your answer to the nearest integer. So this is an example of exponential decay. And from here, we need to recall the formula for exponential decay, which is y equals to a times 1 minus r to the power of t. Okay? All right, so first of all, since we were given this problem, we need to identify the given information that we will be applying in the calculation. Okay, so we were given here the rate. So this is the rate of decay, which is 5%. That's the R. So there are 53 grams of the substance present. So basically that 53 grams is the initial value. So that's the A. And we were given the time period, which is 25 years. And the question is asking about how much of the substance will remain after 25 years. So we're looking at how much will be left. So from 53, how much will it be after 25 years? Okay, so after identifying the given information that we will be using for the calculation, then we're ready to plug in to the formula. So we have y equals a times 1 minus r to the power of t. So y will be equal to a is 53 times 1 minus the rate is 5%. So 0.05 to the power of 25. Okay, so we can simplify the base. So what's inside the parentheses? So we have 53 times 0.95 to the power of 25. All right, so from here you can see the decay factor. So you have here A, you have here the B. B is greater than 0 but less than 1. That's why it's decay. So if we're going to type all these numbers in on the calculator, so make sure to type it in one go. So it's going to give us an exact answer of 14.701 and 64738. But the question asks you to write the final answer to the nearest integer. Okay, so the final answer will be approximately equal to 15 grams. So if you're going to interpret that answer, so there will be approximately equal to 15 grams of substance, which was initially 53 grams, that will be left after 25 years, following this rate of decay, which is 5% per year. Example number 3. If you want to answer this question, feel free to pause the video. When each bacterium splits into two new cells, it doubles. This rate is considered to be alarming. By the end of one day, how many bacteria will be present if there is one bacterium to start with, which can double every hour? Basically, this question is an example of exponential growth, okay? Bacteria growing. So at an alarming rate, so it says it doubles, okay, every hour. So those are the information given that we will be applying in solving how many bacteria will be present after one day or 24 hours. Okay, so recall the formula for exponential growth, which is y equals a times 1 plus r to the power of t. A is 1 because it's mentioned here that if there is one bacterium to start with, and then you'll have this fixed 1, and it says here it doubles every hour, right? So it only tells us that the growth factor is double, right? The growth factor doubles. So 1 plus 1. So that means that the rate is 100% or 1. And the time period, it says end of one day. Remember, the bacteria grows, it doubles every hour, right? And the time period says end of one day. So basically, you need to convert that to hours. Okay, so one day, we have 24 hours. So the time period will be 24. And simplify the right hand side. So we have 1 y equals to 1 times 2 to the power of 24. 16777 bacteria after 24 hours. So this is the exact answer. So example number 4. You bought a new computer for $1,850. After a couple of months, you learn that the value of the computer depreciates at a rate of 40% yearly. When will your computer have a value of $500? So the keyword here is depreciates. So that is decay, right? So you have appreciates, its growth, depreciates, opposite. So that's decay. Okay, so for this question, you also need to recall the properties of logarithm because this question is asking about the time period. So when, right? It says when will your computer have a value of $500? Okay, so this is also an application of logarithm here. Okay, so let's take a look at the, let's start solving the question. So we have y equals to a times 1 minus r to the power of t. We were given these numbers. So $1,850, which is the initial value. And we have the rate, 40% yearly. And this $500 is actually the future value. All right, so let's plug them into the formula. So y will be 500 because that's the future value or the future amount. And a is the initial value, which is 1,850 times 1 minus the rate is 40%. So 0.40 to the power of t. T is missing. So that's what we need to solve for. All right. And from here, we can divide both sides by 1,850. All right. So if you guys need to recall the properties of logarithm, you may check out two of my videos I uploaded. Okay. So I have videos about compound interest, which I uploaded recently. There are two examples there that talk about this. Also, there's a separate video about properties of logarithm that you also might want to check out. So I will be posting the links to those videos in the description box so you can check them later. All right. So going back to the examples, so we divided both sides by 1,850. So 1,850 divided by 1,850 is 1. So the left-hand side, if you're going to simplify 500 over 1,850, it's going to give us 10 over 37 equals, so we're left with 1 minus 0.40 to the power of t. Well, actually, the 1 minus 0.40, you can simplify it to 0.60. There you go. Now, from here, this is when the property or the concept of logarithm kicks in. So basically, don't get stuck at this stage. So there's the concept of log can be applied in here. So we need to take the log of both sides. Okay, so remember you're dealing with an equation. So whatever you do on the left, you should also do on the right. So take log of both sides. And from here, we copy the one on the left hand side. So log of 10 over 37 equals, so another property of log that we need to apply here is the exponent t will be put down forward, which will become like the coefficient of the log. Okay, so it's going to be t times log of 0.60. There you go. And from here, we can see that we can divide both sides by log of 0.60. Then log of 0.60 divided by log of 0.60 will be equal to 1 or 1t. What will be left on the right hand side? So t, and we'll have log of 10 over 37 divided by log 0.60. So you need to type this whole thing on your calculator, like the whole thing in one go. And if you do that, it's going to give you an exact value of t equals 2.5612122. All right. And since the question is asking when, so we're talking about the number of years, right? When the value of the computer will be down to $500. That was initially bought for $1,850. And for the final answer, we can write approximately equal to 2.6 years, right? So if you're going to interpret that answer, after 2.6 years from the time the computer was bought, the value will be going down to $500. So for your challenge, so you grab your pen and paper and solve this question. The population of Old River Town in the year 1995 was 8,772. The town's population has increased at a rate of 4.5% every year. When will the population reach 40,000? All right, if you know the answer to this question, please remember to leave a comment with your answer in the comment section below. Also, if you like this video, please like and share. Please also subscribe to my channel if you haven't subscribed yet. And once again, thank you very much for watching and supporting my channel. It's a great help. By the way, thank you very much and see you on my next video. Bye guys.